Trig equations and identities, addendum page 5, number 5. Simplify using the compound angle formulae. So here's the one that this reminds me of. Do you see how it has cosine, cosine, sine, sine? So cosine, cosine, sine, sine, that reminds me of the cosine A plus B formula. If you remember, the cosine A plus B formula has the two angles that you add together, cosine and sine, and minus 1 from the other. And here we have that same thing. Now, what's weird about this one is, do you see how, like, the capital A is actually alpha plus beta, and capital B is alpha minus beta. So when you rewrite it as cosine of A plus B, you're going to put the yellow one in for A and the green one in for B. So you're going to have cosine of alpha plus beta plus alpha minus beta, right? Because this is yellow and this is green and they're added together, right? And so what we're going to do is we're going to combine the alphas, they're both plus, and then we're going to cancel out the betas because one's plus and one's minus. So we get cosine of 2 alpha is the answer for this one. C. In this case, we all again have cosine, cosine minus sine, sine. So we're going to use, once again, this formula. And in this case, we have alpha as our A. And then we have beta minus alpha as our B, right? So let's write out the substitution. It would be cosine of yellow plus green. So we would basically have cosine of alpha plus beta minus alpha. So the alphas would cancel each other out, and we're left with cosine of beta. Find the exact value of tangent of 5 pi over 12. Okay, so we do memorize values of multiples of pi over 6 and pi over 3, but we do not memorize any values of when the denominator is 12. So this must be 2 angles added together or 2 angles subtracted. So let's think about this. 5/12 pi, couldn't that be rewritten as maybe as 2/12 pi plus 3/12 pi? Now, 2/12 pi is actually pi over 6, which we know the tangent and the sine and the cosine of. And 3/12 pi is actually the same thing as pi over 4, which we also know the sine, the cosine, and the tangent of. So let's use that identity. Actually, this is the identity I'm talking about. Tangent of A plus B equals the tangent of A plus tangent of B over 1 minus tangent A tangent B. Okay, and in this case, A plus B, I'm talking about the 5/12 pi, which is pi over 6 plus pi over 4. And then we just need to find the tangent values of each one of these. So I'm just going to draw little triangles to represent, for example, pi over 6 is 30 degrees. And basically the proportions on this right triangle are 1, 2, and square root of 3. And for pi over 4, which is 45 degrees, the proportions are 1, 1, square root of 2. So basically when we find the tangent of 30 degrees, it would be 1 over square root of 3. And when we find the tangent of 45 degrees, or pi over 4, it will be 1 over 1. Okay? So I'm just going to write those here so we don't have to. Let's see, pi over 6 equals 1 over square root of 3. And the tangent of pi over 4 is equal to 1. So now I'm going to fill in this formula here. So we're going to have tangent of 5/12 pi, because 5/12 is equal to pi over 6 divided by pi over 4, or pi over 6 plus pi over 4. So we could rewrite that as the tangent of A, which is equal to 1 over square root of 3, plus the tangent of pi over 4, which is 1, and that's divided by 1 minus the tangent of a, 1 over square root of 3, times the tangent of b, which is pi over 4. Oh, I'm sorry, not pi over 4. 1. Okay? Now let's see if we can simplify this a little bit. 1 over square root of 3 plus 1 would be 1 plus square root of 3 over square root of 3. And then the denominator, we would have 1 minus 1 over square root of 3 would be square root of 3 minus 1 divided by square root of 3. Maybe there's one more thing we could do to simplify this. What if we multiply by the conjugate to rationalize the denominator? So on the bottom, we're going to multiply by square root of 3 plus 1, and on the top, we're also going to multiply by square root of 3 plus 1. The bottom is going to end up being square root of 3 squared minus 1 squared, and the top is going to end up being square root of 3 squared plus 2 square root of 3 plus 1 squared. And so the top is going to be 3 plus 1, 4, plus 2 square root of 3, and the bottom is going to be square root of 3 squared, which is 3, minus 1, which is 2. So that would give us 2 plus square root of 3. Okay. All right, number 9. If tangent of a is 3/4, then find the tangent of a plus pi over 4. So we know that the formula we're going to use is this formula, remember? So we have basically angle A plus angle pi over 4. And so let's figure out expressions for the tangent of each. So we know the tangent of A is pi over 4. What is the tangent of pi over 4? The tangent of A is 3/4. Tangent of pi over 4 equals 1, like we found above, right? And so our formula is going to be the tangent of A plus pi over 4 is equal to tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. So it would be 3/4 plus 1 divided by 1 minus 3/4 times 1. So basically that gives us 7/4 on top. It gives us 1/4 on the bottom. The 4's cancel out, and we end up with 7. Okay, last one, 11. If sine of A equals -1/3, and A is between pi and 3 pi over 2, and the cosine of B is 1 over square root of 5, and B is between 0 and pi over 2, find the tangent of A plus B. Okay, so let's draw triangles that have the sine of A equals -1/3 in this interval, and draw a triangle that has the cosine of 1 over square root of 5 in this interval. And then, let's see, sine of A equals -1/3. Let's see, that would be opposite of -1/3, -1, 3. Did I draw one that, no, this triangle that I drew is in the 4th quadrant. This is in the 3rd quadrant. So let me fix that. -1, 3. Okay, so yeah, this one is in the right quadrant. So this would be angle A, is this angle here. And then cosine of B is in the 1st quadrant. And it would be 1 over square root of 5. And this is B. Okay. So we are going to now find the tangent of A plus B. Remember that the formula we're going to use is this one. So the tangent of A, let's figure out what it is. Tangent of A is equal to, let's see, we need to figure out this side using Pythagorean Theorem. So we're going to have 1 squared plus x squared equals 3 squared. So that would be 1 plus x squared equals 9. So x squared equals 8. So x equals the square root of 8. And you see how, since this triangle is in the third quadrant, it would actually be x equals negative square root of 8, right? So the tangent of A would be the opposite, which would be negative 1, over the adjacent, which is going to be square root of negative 8. So the tangent is actually 1 over square root of 8. And then this other triangle, we need to figure out the opposite of this triangle. So we're going to use Pythagorean Theorem again, and so we're going to have 1 squared plus y squared equals square root of 5 squared, which is equal to 1 plus y squared equals 5. So y squared equals 4, and y is equal to positive 2, right? So this would be 2, and this would be 1 over square root of 8. I'm sorry, not 1 over square root of 8. It would be square root of negative square root of 8. Okay. So the tangent of this other triangle of B is equal to y over 1 or 2. Okay. So the tangent of B is 2. So we're going to use our formula. This formula right here is the same one. So we're going to put tangent of A plus B is equal to the tangent of A plus the tangent of B. So that will be 1 over square root of 8 plus 2. And then in the denominator, we're going to have 1 minus 1 over square root of 8 times 2. Okay, 2 plus 1 over square root of 8. 1 minus 2 over square root of 8, which is the same thing as 1 over square root of 2, because the square root of 8 is 2 square root of 2. And then we could rationalize the denominator. We could multiply this by 1 plus square root of 2. And the top we also multiply by 1 plus square root of 2. And so the denominator would end up being 1 squared minus 1 squared over square root of 2 squared, which would be 1/2 for the denominator. And the numerator, yuck, it's going to be 2, we're going to do FOIL here, plus 1 over square root of 8 plus 2 over square root of 2 plus 1 over square root of 16. This looks like it could be simplified. So this becomes square root of 2. This becomes 1/4. 2 plus 1/4 is 9/4 plus square root of 2 plus 1 over square root of 8 divided by 1/2. So I'm going to invert this and multiply, so I'd end up with 2 times 9/4 plus square root of 2 plus 1 over square root of 8. That would give me 9/2 plus 2 square root of 2 plus 1 over square root of 2, because square root of 8 is 2 square root of 2, so 2 times 1 over 2 square root of 2 is 1 over square root of 2. Now for the last step, I'm going to put everything over a common denominator of 2. So that would be 9/2 plus, if I put this over a common denominator of 2, I multiply the top and the bottom by 2, so I end up with 4 square root of 2 over 2. If I want to put this over a common denominator of 2, I multiply both the top and the bottom by square root of 2. So square root of 2 over 2. Which I can combine the 4 square root of 2 with square root of 2, I get 5 square root of 2. So my answer is 9 plus 5 square root of 2 over 2.